Good morning and happy start of the fourth term. This is going to be the lecture for chemistry for week 2. What we're going to attempt to do today is explain that mess behind me. And what this is this is a stoichiometry flowchart that's going to help you know to go from where to where, and I want to try to explain that. And I will also put online a same thing, but a paper version. Just in case you can't copy this down. But let me walk you through what this actually is, and then I'll do a problem that'll explain kind of what it's used for. Okay, so let me explain what's on the board behind me. Anytime you're doing chemistry, you're going to want to be able to know if I have a certain amount of something at the beginning of a reaction, how much product should I expect to see at the end of the day? So if I had a certain amount of ingredients, if I was baking cookies, I want to know, is that going to make 24 cookies? Should I expect 36 cookies? What should I see? And that's what this allows us to do. So for example, let's say I started with a certain amount of information. So give me 1 second. I'm going to pause something. Hold 1 second. All right, we're back. It took a second to write an equation down at the bottom. And I'll zoom into that in just a second. But I think it'll help you understand something. So on this, what I have here is I have something called the mass of the given. So what the given is always going to represent is the number that I gave you to start the problem. So in a scenario like at the bottom, you have a reaction that says you have 2 moles of NaBr plus 1 mole of MgCl2 makes 1 mole of MgBr2 and 2 moles of NaCl. So we know how many moles we have. But what we don't have, what if I said, hey, you have 50 grams of magnesium chloride, got 50 grams in your hand, and I want to know how much salt is that going to make? We want to go from grams of one thing to grams of another. This flowchart will help you go from grams of your given, which for us is going to be magnesium chloride, because that's the number I started with, that's what was given to me. And the unknown, what I'm trying to find, is the mass of the unknown. So how do I do that? Okay, I dropped a marker. So what this flowchart, so to go from mass of something to moles of the given, we follow this red arrow. And I don't know if you can make this out, but what this says is we're going to divide by the molar mass of the given. So I would have to figure out, using a periodic table, what is the mass of magnesium, what is the mass of 2 chlorines, add that all together. Once I get that number, I'm going to divide 50 grams by that. Don't worry, I will do an example just in a second. I would then divide that. Then you're going to do something called the mole ratio. So whenever you're doing stoichiometry, you have to compare apples to apples, so to speak. So the way to do that is moles. So moles of one thing versus moles of another. So the moles of the given and the moles of the unknown. In order to convert from one to the other, we have to do something called the mole ratio. And it's the way you do it is you always take the numbers of moles that were the unknown over the given. And these numbers come from your equations. So the moles of the unknown was 2, and the moles of the given was 1. So my ratio would be 2/1, but I'll write that down just in a second. Once I do that calculation, I would then multiply by the molar mass of the new unknown. The unknown is NaCl, not 2 NaCls, because I already did that in the mole ratio, just NaCl. So I'd take 1 sodium, I'd take 1 chlorine, I'd add them together, I'd multiply my answer coming out of this little cloud, multiply it by the molar mass of the unknown, and then I would have the mass, okay? So I'm gonna, and conversely at the bottom, and we'll do more of these later, but I really wanna just worry about the top half. You can also do the exact same thing if I were to give you a number of molecules of something. If I said I had, this many atoms, I could go from atoms to grams. I can go from grams to moles to atoms, or I can go grams to moles to grams. What I can't do is I don't want to just go from grams to atoms of the same stuff. I mean, you can, but we've already talked about that. You'd have to first divide here and then go the other way, but we're not talking about that right now. We're doing grams to grams. So I'm going to erase this real quick. I'm going to move this problem up. I'm going to show you an example on how to do that. Okay, so give me 1 second. Okay, so here's my problem, all right? And I'm going to follow my flow chart. So what I have right now is I have a mass of our given. I have 50 grams of MgO. So I'm going to start with 50 grams of MgCl2, all right? I'm then going to set up brackets. So on the flow chart, and I'll just use this one to show you, anytime there's a flow chart, so this is where I'm starting. I'm starting in the mass of a given substance. I'm going to divide by the molar mass of the given, and my answer will be in moles of the given. So think of it this way. Each one of the boxes is a number or an answer. Every arrow that you see is a process, like multiplying, dividing, doing a ratio, so to speak. So we've been using brackets. So these brackets are basically an arrow is a bracket. So in order to get from mass to mass, I have to do 1 bracket, 2 brackets, 3 brackets. Let me show you. All right, so we want to start with grams of MgCl2, and we want to end in grams of NaCl. So first thing I need to do is divide by the molar mass. I need to figure out what's the molar mass of MgCl2. MgCl, I've got 1 of these. I've got 2 of those. So grabbing my periodic table, magnesium over here, I see it as 24.3. Yeah, 24.3. And chlorine is going to be 35.5. Add those 2 together. So 1 times 24.3, because I got 1 magnesium, I got 2 chlorines. So 24.3 and 71, add those up. I get 95.3. That's the molar mass. This is the molar mass of MgCl2. So if I'm going to divide by the molar mass, I'm going to do this. 1 mole, 95.3 grams. If I were to stop right there, if I just did that calculation, if I just did that, I went from here to here because I divided by the molar mass. So the answer that pops up in your calculator is going to be moles of the given. We don't want to stop there. We want to keep going. Middle bracket is the mole ratio. It's always going to be the unknown over the given. Always. Unknown over given. Unknown. We don't know sodium chloride moles were 2. 2 moles of NaCl. The bottom is going to be the given. Right here, MgCl2, we used 1 mole of it. So my ratio is going to be 2 over 1. All right. So now I've gone from here. I've done my mole ratio. And now I'm here. I'm in moles of the unknown. So if I were to stop, if I were to take my calculator and take 50, divide by 95.3 because it's in the denominator, that's going to give me moles of the given. If I do my mole ratio, take that answer, multiply by 2 over 1, I am now in moles of sodium chloride. The next step is then to multiply by the new molar mass and get to grams of sodium chloride. So just like I figured down here, I need to figure out what's the molar mass of NaCl. Well, we know chlorine is 35.5 because we just found it out from over here. There's only 1 of them in the NaCl, so I don't have to worry about multiplying it. Sodium's mass, I've got 22.99. So we're going to round that to 23. Add these up. $58.8. I'm going to multiply by the molar mass now. Okay, I've done all my setups. Now let's grab a calculator, grab one, and bang it out. So, calculator. 50 grams. Divide 95.3. Enter. Okay, got like 0.52 something. I'm gonna leave that in the calculator, okay? Now I've got 2 over 1, so I'm gonna multiply this times 2. So take that answer times 2. Okay, I now have 1.043. Gonna leave it there. Now I go from here to here, so I multiply by 58.8. So take that answer times 58.8, and I get 61.385, whatever. So round that to the nearest decimal point, 1 point, so I'd call this 61.4. 64.1 grams of sodium chloride being made from this reaction, okay? I'm going to do a couple other ones, but I'm gonna call this a video for the day. So that way these videos aren't super, super long. So I'll try to do another couple problems here. But until then, signing off.